All right, everyone, welcome back. We're going to keep building on our foundation of core SQL statements and joins, and we're going to start using grouping and aggregating to create higher level analyses and set us up to make some really nice charts in the next video. So when we have a SQL query, we sometimes want to perform what are called aggregations. And what that means is if you think about pivot tables in Excel or performing calculations across many rows. Okay, so let's see an example. We want to get a count of the resources inside of each operation, right? So if we go back to the diagram, we can see, at least in this diagram, there's 3 mixers, 4 bakers, 3 coolers, but let's try to calculate that in SQL in a programmatic way. We can pull a query like this. We've done this in the past where we join our resources and our operations. This is going to be a long list. And if we looked at it for long enough, we could probably count the data that we're looking for. But let's imagine we had hundreds of rows and hundreds of resources. It wouldn't be possible to do by our own. Thankfully, with SQL, we can count across many rows. So just as a quick example, we can count the entire output of this query, and it's going to return effectively the number of rows. So we know from experience that this means there are 20 resources in our database. What we really want to do, though, is understand how many resources there are at each operation. And thankfully, this is pretty easy to do. So what we're actually going to be doing is aggregating with a group by, or a grouping. And so you'll see a very similar output, but what we're going to do is we're going to take one of those columns from MES operations, the operation name, and we're going to add it as an output. Okay? And so now we're expecting a 2-column output where there's an operation name and a count. And all we need to do to finalize this aggregation is group by the results, or form a grouping. And all that is at the end of your query is group by operation name. Now, I am breaking one of my best practices here. I always want to alias each column, even though that query would have worked because operations is the only table with operation name. It's always a good habit to use your aliases whenever applicable. And now, when I run this query, I'm going to get 2 columns, and this count aggregation is going to be applied on each group of operation names. So when I run this, I should see 5, and I'm getting the number of resources in each operation. So to finalize, this is a more production level query. We would name this number of resources, and usually want to order these types of queries. So if we're ordering by a query, remember that order by is always going to come at the very end. So what we're going to do is order by number of resources. And voila, we're now seeing that our chart probably wasn't perfect. I didn't count when I went through this, but we can see that the cooling step only has 2 resources and the packaging step has 6. So already we're starting to identify a good model of this process, right? The cooling step is either very short, or it might be a bottleneck at this manufacturing facility. One more example of aggregations. Let's say we wanted to count the amount of scrap that each operator has created or each operator has performed. This is obviously not a fair way to judge operators, but it might be an important piece of information to understand why patterns are occurring. So just like last episode, we're going to use our inner join to connect to the operator table, right? We could do this with operator ID, but let's make it human readable. So let's add this operators table O, and we are going to join on sl.operatorID equals o.id. Very straightforward. We're joining on the primary key of operator with a secondary key operator ID from the scrap logs. Okay, so we know what this will look like. It's going to be a big, awkward, long list. But most importantly, in this output, there's a column called quantity, which represents how much was scrapped by that operator. So what we can do is, same as before, we can use the O.operator name as our grouping. And instead of counting, this time we can sum the SL.quantity, and it's going to sort of vertically smush, I like to think of it, all the SL records. It's going to smush them using a sum aggregation. And so we'll call this scrap quantity, or maybe total scrap quantity. And then we would want to finish this with the group by O.operator name, right? SQL needs that group by to know how to group this sum aggregation. So now when we run this, same as before, we'll see a 2-column output, only this time it's a sum instead of a count. So we're seeing pretty big numbers here. Some more, likely things you might see here. You might see a count of SL.quantity as number of scraps. So you can apply multiple aggregations. In this case, the grouping is the exact same, so we don't need to change that. Okay. And now we're going to get a number of scraps. And then you also can still apply functions around these aggregations. So here I'm going to round to get rid of all that decimal junk. And voila, we now have a clean table of which operators are performing the most or the least scraps. So let's apply what we just learned and try a practice problem where we're going to, instead of pulling scrap by operator, let's pull the scrap sorted from most to least by month, okay? So if you look back at, I think, episode 1, or if you just use Google, you're going to need this extract function. So pause the video, give it a try, and then I'll go over it. All right, so again, let's just start by select star from MES scrap logs, right? We know we can sum this or count this and get the number of scraps, but what we really want to do is get the scraps by month. And so what we're going to need to do is extract the month from the timestamp. So let's just clean this up for a second. Maybe we want timestamp. We'll come back to this. This will be the month and the quantity, okay? And what we want to do is change this column to be the month. So what we can do is use this extract function, and we're going to extract month from timestamp. And so now we're getting this 3-column report where we can see the different months, but this is still the granular data. We want to summarize this. So all we need to do is set up the aggregate function of what we want to sum. So we would call this column as total scrap quantity. And we actually need to get rid of the more granular row, or more granular column, because that's not going to help us summarize data if we're revealing the timestamp of every record. And so we now have this extract and this sum. The only thing that we need to do now is group by, and we have to group by the same value as we're using here. Now, conveniently, Postgres makes this a little easier and allows you to just use the name of that column. You can totally do this, right? Like this would work. And if we run this, we'll see our result. But thankfully, Postgres optimizes and understands what you're trying to do when you group by the name of a column. And so we're going to get the same result, and this is a cleaner way because it guarantees that this function is what we're grouping on, no matter what. Okay? And it seems like we are grouping or ordering in terms of month. Let's go ahead and order by total scrap quantity descending. And now we have a good idea of which scrap is, or sorry, which month had the most scrap. You can see May was an exciting month. That may be because that's when the work orders just started in my simulated data set, but You get the idea. Okay. Let's apply something similar onto a new problem. So the only trick I want to add here is that if you want to perform an average instead of a count or instead of a sum, you can use AVG as an aggregate function. So with that information in mind, and maybe thinking back to episode 1, what is the average completed work order yield by product? This one's a bit tricky because you're going to need to go from work order, you're going to need to join to product, and then you're going to need to average a calculation. And there are 2 ways to do this. I'm going to go over both, but think about why I might be asking that question. Pause now. Okay, so hopefully that was a good puzzle for you guys. I think this is exactly where we're headed on our path to really grasping SQL and solving problems with it. So let's start by selecting star from ERP work orders. We'll call that WO because we know we're going to need to join to product. Okay, so inner join ERP products P on P.id equals WO.productID. Again, you can do this in either direction. I think normally I've been writing it more like this, so let's keep it standard, but it does not matter. And what we now want to do is create some type of output that looks like this. So we have P.productName, and we want to return the average yield. So let's maybe write this out as a comment. We want to have completed quantity divided by original quantity, right? So that's for every work order, we want this value, and then we want to take the average of all that. So we want to average the completed quantity divided by the original quantity, and we would call that average yield, okay? So let's break this down and turn it into proper SQL syntax. So I would just change this to average. I'm going to alias these 2 columns. Even though the query will work without it, it's always a good practice to alias your columns, right? And so now the only thing left to do is group by this column here that we want to sort of separate the calculations that we're making. And so when I run this, I'm going to get, let's see what the error is. Work order.origin. Need to make sure we have our columns correct. And now we can see this pretty interesting yield column, right? Now, when you're doing data work, it's really important to have a good foundation of simple math and the way that these data points can lie if you're not careful. The thing is, what I'm doing here is I'm averaging each of the work orders equally as a part of this yield calculation. If you've dealt with something like this before, you know that these types of calculations can be heavily distorted by very small or very large work orders. And so when you're doing this type of calculation, it's usually best to do what I might call a weighted average yield, where larger work orders matter more than smaller work orders. And the way to do this is actually to not use the average at all. It's really to calculate it yourself. And so the same way that we can use the average already, we can do a sum of work order dot completed quantity, and we can divide the sum of all completed quantities by the sum of work order original quantities. And this, if you pause the screen and kind of think through it, it's the exact same type of calculation, except it's going to sum. So if you had 10 work orders for 1,000, this will be 10,000 completed. And if you had 10 work orders with an original quantity of 1,500 maybe, this will sum to 15,000. And so this aggregate measure in that case would give you 2/3. So it's the same result as averaging the individual calculations. And so now we can run this and we'll see the two columns next to each other. Again, really cool to see that you can have the same exact calculation. You can have multiple calculations as separate columns on the same grouping. And we can see we get very different results when we factor in the weights of each. Okay, let's do one more practice problem here, round out the episode. How much inventory by product are we expecting from current incomplete work orders? Okay, so think about a way to filter to the incomplete work orders and then sum the quantity of those. For this, let's assume they all complete with 100% yield. Okay, pause and give it a go. All right, so again, select star from ERP work orders. Let's take a look at what we're working with. And what we need to do is find all of the columns that don't have a completed quantity and count the original quantity and sum that all together. So actually a very quick query here. All we're going to do, we are going to sum the original quantity from ERP work orders where completed quantity is null. Now this is a new piece of syntax, and I want to point this out because you'll see it quite often. Anytime you have a null value, it's going to operate a little differently than a 0, for example. In SQL, if you want to find rows that are null, or you want to ignore rows that are null, instead of doing equals null, it's actually is null. And the same if you wanted to do is not null, that would give you the records which are completed. So anytime you want to ignore null rows, you can do if you want to look for only null rows, you're going to use is null. And so now when I run this, I'm going to get a number. How much inventory are we expecting? Okay. And the last piece of this, we want to group by product. So now I can build on to the foundation that I've established. So I can find erp.products, p. Let's go ahead and alias everything. This is probably a good example of why you should start with your joins and then add everything else. Makes it easier to sort of think through the problem. On p.id equals wo.productid. And then all we're going to do is add a grouping to this whole thing. So p.product name as a column. And then we're going to add the group by after the where clause. Again, the group by always comes after your filters because the group by isn't doing anything until you've filtered the inner piece of the results. So then group by p.product name, and let's clean this up. So expected inventory, and then finally let's order by expected inventory descending. And now if you're a planner at a facility, you can get a really good idea of how much of each product you're expecting in the future, right? And so this is just based on upcoming work orders, which I believe for this data set is only 30 days. But if you imagine a longer time horizon, you could add an additional layer of grouping for month or week or day. So the possibilities are endless here. I hope this was a good foundation to really grasp the concept of aggregations, and I'll see you guys in the next video.